State the law of conservation of angular momentum. Now, this law is very similar to the concept.
Hey guys, good evening. Welcome. We're doing some GCSE physics revision. I hope we're doing well. Hope you had a nice half term. Back to it tomorrow. Hope nobody's got a too bad case of the Sunday blues. Although everyone gets them, teachers get them as well. Anyway, so today we're looking at magnetic fields. So if you see my story, you would have seen lots of hopefully posts from me this week because I don't know, it's half term and it's ramping up to a little bit of GCSEs. So today we're looking at magnetic we're going to go through in we've got 6 weeks to the whole of paper 2 basically. So hi guys, welcome. We just started. If you could like the stream, that'd be amazing. So this is the first one I've done for a little while. I did these quite a lot last year and did a bit before Christmas as well. So we're doing magnetic fields tonight. We're going to start off with some sort of warm-up questions. I know magnetic fields can be quite a tricky topic. Then we're going to move on to some of the higher tier questions. But this will be for AQA, LXL, higher tier foundation tier. I'll tell you if there's higher tier stuff that comes up basically. Anyway, if you guys could give the stream a like, that'd be amazing. Hopefully the sound quality and everything you can see is all right. And if you know someone, if you've got a mate who, I don't know, who's got physics paper 2 PP coming up at some point, that'd be maybe give them a share. Get them in and drop a follow if you haven't done so already. Right, so let's do these. A couple of warm-up questions. This is from foundation paper, but all foundation questions could come up on a higher tier paper as well. So there's a compass here, which are very important to magnetic fields. It tells you there's a north and a south pole. So the question is, why does the compass always point in the same direction when it's not near a magnet? If it's near a magnet, it's a different story. But should we see if we can label these A, B, and C? Do you want to put in the chat, people, for the very first question of the day, which of these do you think it might be? Is it that the compass is not magnetic? Is it that the Earth has a magnetic field? Or do you think it's because there's no force acting on the compass? So this is without a magnetic field from a magnet present. Why is it that all compasses will point in the same direction? Just, I don't know, if they're around your house or just all on the table or something like that. Amazing, great stuff, well done. It is due to B, fantastic. So if you didn't know, fun fact, not for this question, you don't need it, but the reason magnets point towards, so where technically the North Pole points that way, is because the Earth has a little South Pole near the North Pole, which I know is really weird, but that's because that means that compasses, because they have a little north near there, that end will point towards that direction there. But that's very odd. Right, next one, what material could it be made out of? So we're looking for a magnetic material here. I'll label these A, B, C, and D. You can either write the answer or you can write down the letter if you would like to. So what material? Aluminium, copper, plastic, or steel? Which of those do you reckon might be the one that this thing could be made out of? So looking for the magnetic material. Amazing. You guys are on fire tonight. Lovely stuff. Mostly saying D. It is D, correct. It's steel. All right, there are 3 others. Steel is the only alloy. There are 3 magnetic elements which you need to know about for GCSE. So bonus question. Do you want to see if you can write in the chat if you could tell me magnetic elements, or basically the 3 other magnetic materials? I'll be very impressed if anyone gets all 3. Cobalt-y. Justin's autocorrect going on here. Amazing. Well done. I think Evie and a couple of people were first. Yeah, fantastic. So iron's the kind of obvious one. Most people remember that because of iron filings. And then there's nickel, and then there's cobalt as well. So steel is included as an alloy, but it's lots of things made out of steel, like paper clips and stuff like that, that are magnetic as well. Awesome stuff. All right, let's have a go at the next one. Now this gets a bit trickier. This is to do with a solenoid, which it doesn't actually tell you that in this question, but it just says it's a coil of wire, which it's the same thing. That's what a solenoid is. And questions involving these tend to freak people out more so than bar magnet questions because I know they're a bit weird. So the technical name for this is a solenoid. And what we've got to do first of all, actually we'll do this one first, then we'll do the drawing afterwards. It says, which statement describes the magnetic field around the coil? So if you can't see, if it shows up all right, you've got these lines here, the magnetic field lines going around it. We haven't done the compass bit yet, but which bit describes magnetic field? Is it the same at all points? Is it stronger further away from the coil, or is it strongest at the ends of the coil? Which one do you reckon might be correct for a field around a solenoid? So put your answer in the chat if you would like to. Awesome. So if you just joined, we're doing some of these are foundation-y type questions. We're going to move on to some of the harder trick stuff later, but I thought we'd do a nice little warm-up. And if you haven't followed or don't follow me, then we're going to do these every Sunday for the next 6 weeks till Easter, basically. Well done. It is C, correct. So the field is strongest at the ends. Does anyone know? I mean, we kind of know that because you pick up stuff with magnets, right? Does anyone know, just by looking at this diagram here, like if there was a follow-up question, how do you know? What information does this diagram tell us that tells us it's strongest at the ends of the coil? Because most of you guys got that spot on. But how would I know that? Basically, would be the right follow-up question. Could be a 1 or 2 marker, probably 1 marker for that. What is it about the field lines that show you that it's the strongest at the ends of the poles? Amazing, yeah. Nice one, Layla. Well done, Hannah. Yeah, lines are close together. Or you could say there's more field lines as opposed to this bit here. There's hardly any, where there's a higher concentration of field lines at both ends. They're equally strong overall. Okay. Right. The next one is actually 2 marks for this, which is quite nice. To draw an arrow in each circle. So these circles up here to show the direction of the field lines. All right. So obviously I can't really ask you guys to draw it, but do you want to put in the chat what's the rule that governs which way field lines are going? So if I was to have a compass at each point, which direction would it be pointing in, do you reckon? And then I'll try and draw those accordingly.
Figure 1 shows a gas discharge tube devised by William Crookes.
Amazing. Nice one. Lovely stuff. Well done, Clara. Well done, Evie. Yeah, north to south, okay? So to north to south, you have to draw them coming out, like away from the north. So you draw an arrow going that way, away from the North Pole. And then it goes into the South Pole, basically. So towards the south, away from the north. That in between, they're just looking for it going in this direction. So imagine you actually follow these field lines. That would go somewhere to the right like that. And then this one here would do the same, but it goes sort of up and around. So it goes in that direction. Okay. So I think some people would either go up or down there, but be careful. It goes out to the north and into the South Pole. Okay. Right, let's finish up this question, then we'll move on to stuff a little bit harder potentially. So if you just joined, welcome to magnetic fields tonight. These are 2 marks here for looking at the ways in which the field could be made stronger. So how can I make the magnetic field stronger? This is such a common question you would not believe. So it could apply to like electromagnet, it could apply to motor effect, which we'll come on to later. How do I make that field stronger? So if it was electromagnet, it looked like this, but it's the same sort of deal. Would you want to put your answers in the chat? So no letters for this one. What do you reckon? How to make the field stronger? 2 ways we're looking for here. What do you reckon? Okay, people got some answers, which is great. Okay, cool. Yeah, well done. Okay, brilliant. Well done if you said any of these things. So adding an iron core. I kind of gave you a hint about that a second ago, didn't I? So if you add an iron core, that would make it into an electromagnet, which is this one here, which you're absolutely right, that makes it stronger. You could add more turns to the wire, or you could add, make them close together, something like that. I saw a couple of people say more coils. Like, I know this is really picky, but you're not allowed that. Okay, more coils would not be correct, because if I show you the diagram again, this is 1 coil of wire is just like that. If I was to add more coils, that would mean have more of those. That doesn't mean put them tighter together, if that makes sense. So you just add them, like add more turns to the coil. You don't add multiple coils. That's a really common mistake. Okay. The other one you could do is to increase the current, which I know people said. So increase current, you could say increase the potential difference or the voltage as well. That will be absolutely fine. So I've listed 3 there, but you only need 2 for the mark. What would best way to get some last minute revision for a physics mark? Depends when it is. Have you got a week? Have you got a day? Have you got 2 weeks? I would say in terms of revision, like you want to make sure general principles are that it's active. So like you want to make sure you're not just watching a video or reading a book. So that would be like notes or flashcards or something like that. And I think while you can buy flashcards, you get AI to make them. You need to be active in that process. You need to be like actually either making them or reading them and sort of testing yourself on that knowledge. And then apply. All right. So active recall, testing yourself regularly on that, and then apply. And that's the magic word. Past paper. So past paper questions from physics and maths tutor, something like that. I would probably avoid doing a whole past paper until you're quite close to it. 3 days is all right. Got loads of time. I think I've got loads of time. But anyway, yeah, those are the 2 principles. So it depends what you want to do. You should know places to go to get past paper questions. For physics, if you don't know, I've got a whole video on the whole paper too. So like, depends if you're doing triple or not, then you can have a look on there. That might be a good idea. That's paper 1. Paper 2 will be somewhere right there. And it's an hour and a half long. So it depends, you know, if you can last an hour and a half or just split it up into chunks, that'd be not a bad idea. Okay. Okay, right. Are there any other questions on this? If you have got questions, please ask. Like, I've been a physics teacher for 11 years now. Jeez. So if you, like, I've taught AQA for most of that time. So if you have any specific questions or general questions, then give me a shout. I can I've answered those ones. Sweet. All right, we'll move on. So we'll go next one. So what I'm doing tonight, that was, if you didn't know, that was what was that? June 2022. That paper, resultant force moments. I'm going to do that next week. So if you have a look, I think I put on my story earlier. Next week we're doing forces in motion. Okay, so that won't be there tonight. All right. Well, they asked about the practical. Which practical? Magnetic fields. Could do. I mean, they love asking practical questions generally. If you don't know the required practicals, there isn't one on magnetic fields. But they could ask about a practical with magnetic fields. Yeah, why not? Right. Anyhow, okay. Any general questions? Keep them coming in. That's a really good questions there. Right, move on to something slightly trickier. This is another paper. Which one's this one? 2020. Which slightly longer answer questions. And then we'll have a look at some higher tier stuff, which is motor effect and all that stuff. All right. So we've got 5 different metal samples. You can read the elements here: iron, steel, aluminium, copper, tin. And first of all, the student says the question says the student placed a magnet close to each sample, and basically we've got to describe what happened. So there's actually not lots to highlight here. But right, you guys remind me. I know it was only a minute ago, but what were the magnetic materials out of these 5? Do we think which ones that we talked about were magnetic?
Figure 1 shows a gas discharge tube devised by William Crookes.
Yeah, awesome. Well done, Jada. Well done, Bridgie. Well done, Evie. Loads of other people as well. Well done. Yeah, these two here. Okay, so conveniently on the left-hand side. These are 2 magnetic ones. So if you can start writing answers, that'd be amazing. It's interesting. This question is 2 marks. I think it seems like one of those questions where you've got to waffle a bit for 2 marks, but it's one of those questions where you actually don't have to write lots to get the second mark, basically. Hannah's on the right lines. Well done. So basically, if you place the magnet close to each sample. The key word here is attract, because magnetic materials will attract to magnets. Okay, that's kind of what they do. So what we'd say, and we'd prove our knowledge, so demonstrate our knowledge there by saying iron and steel attract. Oh, I can't spell steel there. Still, there you go. Iron and steel are attracted to the magnet. So that's your first mark, and then the second mark is basically saying the others won't, which I know sounds like such a dumb mark. But like, I don't know, get those dumb marks. If you see it's 2 marks, you've got to say an extra little thing. Won't be affected. The others won't be affected or won't be attracted or something like that. Okay. Now, here's a really important thing. If you've got iron and steel, it can never be repelled away from a magnet. Okay, you can't be repelling. High paper. Question after this. All right. This could all be on a higher paper, though. Don't forget, people, like higher and foundation tier, there's always overlap between them. So I don't want people to think like, oh, it's not like in maths where you just do higher or foundation. The hardest 2 questions on higher tier also come up on foundation, and the easiest 2 questions on higher tier also come up on foundation, and the hardest foundation come up on higher, basically. What makes iron steel attract to the magnet again? Because they are magnetic. So you wouldn't be asked that kind of question. Basically, it's harder than you think. Basically, people couldn't write whole books on what makes stuff magnetic and videos and stuff. But inside magnetic materials, it just means they're quite easily, the atoms in there are easily aligned so that they line up with a magnetic field when it's applied. That's just iron and steel are magnetic. So that happens to them. It doesn't happen to the other 3 questions. Domains. Well done. Which, on AQA, you're not expected to know that word or exactly this, but that's kind of why it happens. But it's kind of interesting because we dumb it down a bit at GCSE, magnetism and electromagnetism. What is quite a good, useful word to know is if you do put an iron nail next to a magnet, I'll be superimpressed anyone knows. What is this called? There's a special word that's called when you put an iron nail next to a magnet and it gets attracted. It's got a special name. So this is not in this question, but just a general topic. This is one of the harder bits on magnetic fields. Anyone think they might know? What do I call that? If I have a nail, but put it next to a magnetic field, it's got a special name. Amazing. I was absolutely flying this evening. Yeah, it's called an induced magnet. Okay, so basically, when you put an iron nail or something magnetic close to a magnetic field, it turns into its own little magnet with a little north pole, a little south pole. Okay, that's why it gets attracted. So that's called an induced one. Okay, let's have a look down below. If you've got any questions, keep them coming. This is good so far. So paper 10 shows a paperclip being attracted. So you've probably done something like this in school, they're practical or something similar. The paperclip is not a permanent magnet. So that's our key bit of information there. Explain what would happen if a paperclip was removed and brought close to the south pole of the permanent magnet. So basically you take off the paperclip from here and you move it over here. Again, it's 2 marks this question. So, right, do you want to write your answer? What do you think would happen? So the options are, it could be repelled, it could be attracted, nothing could happen. What do we think it might happen if we put that one to the other end of the pole? Any ideas? Okay, spot on a couple of answers. Don't be afraid to guess, people. All right, if you don't know, it's fine. I don't teach you. Not gonna have a go at you. He's going to attract. Nice one. Well done, Evie. Yeah, fantastic. So the idea is it still attracts. Okay, so the key part is here. Iron, like any magnetic material, is attracted to both a north and a south pole, and not just one. All right. So the iron, or the sorry, it's not iron. Oh, it could be iron or steel. Doesn't really matter. Any magnetic material. So let's say, stick with what it says in the question. The paperclip. I'm a nightmare here. Can't spell anything. Right. Paperclip is attracted to the south pole. And genuinely, this was actually a coincidence. I asked about this term here because the second mark, and yeah, well done, you got it spot on, is it is an induced magnet. So it basically becomes like a temporary magnet and gets attracted to the south pole as well as the north pole. All right, so that's your first mark here. Is it gets still attracted, and the physics behind that, and the key word there is it's an induced magnet. It becomes a magnet sort of temporarily, basically, it gets attracted to this bit up here. All right. So that's the end of that question. I'm not going to do the rest of it. It's just like a forces bit, which I'm trying to stick to magnetic fields tonight. But has anyone got any questions on that? If not, I'm going to move on to some higher tier stuff, which might not be everyone in the room, but is tricky, and I want to go through. But any questions on that, give me a shout while I'm just loading up the next paper. Sweet. All right, we'll get started at that then. If you've just joined, welcome. Doing some physics revision tonight. This is sort of past paper practice. Can a metal become an induced magnet? No, just those magnetic materials. So just the iron, steel, cobalt, nickel. There are other compounds as well, but you don't know about them at GCSE. So just magnetic ones. All right. So yeah, doing magnetic fields. Now this is higher tier. Okay, so I know I said earlier, like everything's suitable for everyone, and there's going to be some things in here that are just for higher tier students. But that does not mean it's just separate only. That means it could be like double or triple or combined or separate, basically. But just means it's only if you're doing a higher tier. My spelling is getting awful tonight. Okay, and that's because it's all to do with the motor effect. I love the motor effect. I think it's amazing. But it's kind of tricky to get your head around. Okay, so in this question, so this is from a higher tier paper. This is from June 2022. You've got a magnet. We've got a current carrying wire. It's this stuff. All right, you've probably seen this stuff in class. I don't know, you've probably done, most of you will be finishing the whole course by now. We need to know basically what this is. You talk about Fleming's left arm? Yes, you would, exactly. But that comes a bit later on, all right? Now, I'm going to explain it briefly. I'm going to explain why there's a force, and then the direction of the force is Fleming's left-hand rule. FBI, that's the one. Yeah, exactly. Yeah, I don't know. Do people, we'll come back to that later. Let's do this bit first, all right? So the first bit is why there's a force on the wire. When there's a current. All right, so basically, if you haven't seen this as a demo or if this is new to you, essentially what happens is when you have a wire in a magnetic field, it moves either up or down. In this case, either up or down because it's perpendicular to the field lines. It kind of jumps. It's kind of magic. I love it. I think it's amazing. But the reason it happens is due to magnetic fields. All right. So one thing we need to know about when I've got a current, so I'm just going to draw an extra diagram down here. I've got a wire with current flowing through it. The electrons that flow through cause their own very, very small magnetic field to be created around the wire. Okay. Now, that magnetic field, they are circular. They are quite small because the current's going to be quite small, but they are there, and they're there on this this wire as well. So I don't know why I drew an extra diagram. So this one. So they go round and round and round. So basically, you have two magnetic fields going on, which I know sounds like slightly insane, but that's what's happening. But it's due to, in a wire, when you have current flowing, basically electrons, because they have electric charge, they cause a magnetic field to be induced around them. Okay. Now here's the weird bit. Okay, it's careful how you phrase it, because this is only 2 marks. If you had a longer question, like a 5-mark question about a motor, you'd have to be really careful how you say it as well. But basically, that magnetic field interacts with this magnetic field. So there's a magnetic field between north and south. I'm just going to draw in green. So there's 2 magnetic fields going on. For GCSE, the keyword is to say those two fields interact with each other. Okay. Technically, what happens is they reinforce each other. I can't really draw that because that's way too hard to draw. But they interact and reinforce each other. That's the extent at which you could ask about GCSE. Okay. If you do A-level physics, you'll learn a bit more about sort of why that happens or what's actually going on. So our first mark is for saying there is a magnetic field. So basically, what I just explained. There's a magnetic field around the wire. So that's a mark just for saying, well, for stating that you know that, even though the question is kind of too obvious that there's a north and a south pole. There's definitely a magnetic field, but then we say essentially it interacts with. You don't need to say the word permanent, but I'm going to say it here. So permanent, basically the green field, the permanent magnetic field between the north and south pole. Okay, so the permanent one's the green one, so I'm just going to label that in green. That's the one I've drawn there, and the other magnetic field is the red, the little red one there. Okay, that's the general theory and the physics theory behind why how any of this stuff works. Basically, it's the idea there's those two magnetic fields. All right, so that's motor effect. It's one of the trickiest things. Trickier still is this business. All right, which is Fleming's left-hand rule. So. All right, people impress me. All right, what does each thing stand for? So someone said FBI earlier. That's great to know, great to learn. But if we can tell what each finger stands for, that helps us even more. So this is high tier only stuff. All right. Okay, type in the chat if you think you know what does the which one should you do first? What does the thumb represent with Fleming's left-hand rule? Do you know? Sorry, on GC physics? No, absolutely not. People start revising every year this time and get 9s and 8s. Oh, people do it all in one. Amazing. Nice one, Clara, Beth, and some other people as well. Yeah, the thumb is the force. So I'm just going to write this down here, okay? Because this is, you do get marks for this in the question. So your thumb represents force. Now, a way of remembering that is, well, so I'll do the remembering stuff at the end, all right? Okay, first finger. Some people have put in the chat array, which is great. Represents the field. And then the second finger. I forgot to write first finger there. Second finger, that represents current. So well done if you put all those in already, which is amazing. Yeah, the way I remember it is I actually go, I don't know, it's bad because I remember thumb as motion, but you don't usually get marks for motion. You get marks for saying force. So, but if I remember it's motion, that's the way it's moving, I can remember to do force. First finger is field. That's quite easy, okay? First finger, that goes in the direction of the magnetic field. So that's north to south. All right, so it has to be N to S. Then we've got second finger. That represents current. I always remember that because second has got a C in it and current begins with a C. All right. FBI, if you didn't know it, where's my equation sheet? Oh, yeah. FBI is quite nice to remember because F is force. B, you have to remember is flux density. But because you've got the equation sheet this year, there you go, this thing down here, you've got the idea that B is magnetic flux density, basically magnetic field, and then I is current, which you probably should know from all the other equations as well. So yeah, FBI is not a terrible way of remembering it. Maybe I should, now we have the equations, maybe I should teach that more to my class. Just quickly, what do you guys learn? Do you learn FBI or do you learn like the letters M and F and like C and all that stuff? Or there might be other ones, I don't know, maybe there's different ones, FBI. Okay, cool. Bit of a mixture. That's fair. Yeah, fair enough. I mean, whichever one works for you. I'm sure there's other ways. Like, I always encourage people to make up ways of remembering stuff because then it helps you. Tips for learning or content. Beeping. Oh, is there beeping in the background? Not good. Yeah, get rid of that. Oh, that might be. Oh, I think that's because I've got an ad on physics and maths tutor, and they're really bad with ads these days. I thought I muted it. I think I did mute it. Okay, my bad. Sorry, I'll get rid of that. Okay, let's go again. Has that been going the whole time? I can't hear it because I've muted it. Yeah, there we go. Is that genuinely going the whole time? Thanks, Jada, for telling me. If any stuff like that happens, just give me a shout. I can usually change it. No! Oh, my days. All right. You should have told me earlier because I can definitely fix that. Okay, no worries. I should not mute my laptop so I know what's going on. Okay, I think that's gone now. Happy days. Okay, right, peace and quiet now. Okay, what did someone ask? How to member on your own? I would do. You didn't realise, okay. Depends what volume you've got it on. Thumber's motion, yeah, I'd go with that as well. Okay, so someone was asking about how to learn all the content. So I asked this whole question about this earlier. I would make sure you are like using either a video or revision guide or something like that, and making either notes or flashcards on it. And I know some people you can buy them and stuff like that, but being active as you can. If you don't know, this is my YouTube channel. I put loads more stuff on there than I do on TikTok. Like this is kind of TikTok's quite new for me. But I've got a video. We got the whole of paper 2 in like an hour and a half, which won't load now because it's got an advert. But yeah, then I would do exam questions. So go physics and maths tutor to try and apply it, or something like that to try and apply it. Yeah, using the spec as well. Yeah, definitely. So specification. Here's the order, right? Here's top tip from teacher. Okay, so what is the best thing to use and the thing you should rely on is the specification alongside exam questions from like current spec, so anything after 2018. That's greater than like me, so any videos, revision guides, even your teacher, depends. I don't know how much you trust your teacher, but like those are the two things where that's how you get grade 9s, is by doing loads of exam questions. Yeah, using the specification. Because every now and again I do a video and I'm like, I look at the specification, I'm like, oh, I didn't really know it was phrased like this. I didn't know this was in there. I didn't know this wasn't in there. So yeah, those are the key things I'd say. Depends what grade you're aiming for, but be active with it. Take notes. Try and memorize them like regularly, like active recall, and then questions. I would say. How do you spec properly? Print it out or get a copy on like an iPad or something like that and annotate things you don't know. And then I would make flashcards on them or notes on them. You can get ChatGPT to do that yourself, I think, if you wanted to. Yeah, but basically and they can't ask you anything that's not in there. That's the same for biology and chemistry and physics as well, honestly, like all of them basically. You're welcome. Right, should we finish up this question? And I'll show you. Oh, hold on. We didn't finish up this question, did we? All right. So we've got to predict which way this goes. We've got to actually apply Fleming's left-hand rule. So should we do it together? So basically, the mark in this question is what the thing represents, and then the idea is you sort of explain what I've just did. So hold thumb, first and second finger, basically perpendicular to each other. Perpendicular. Okay, right. It's going to be quite hard for you guys on the screen, but do you want to have a go? So first finger north to south, current, try and figure out which way is it going to go. Can you think which way is the wire going to move when it's on these, when it's in this situation here? I'll give you clues, either up or down. What do you reckon? In questions like this, it's usually going to be 50-50 or 1 in sort of 4 chance. So they're actually using it. You can't really be asked more than 1 mark for it. Wait for a couple of people to have a go. If you don't know, I can help you out. Here you go, north to south. This finger goes away from you because it's got to go in the direction of the current. And then if you do that, you've kind of got to hold your phone in the right hand or whatever you're using. Yeah, your thumb should be going downwards. So the wire is going to move downwards. So that'll be your final mark, basically. Wire moves down. Yeah, so Fleming's left-hand rule is just as important to know this stuff as it is to be able to apply it, just because that's only ever going to be 1 mark, I would say. Yeah, I know what you mean. You know what's harder is motors. They can be even trickier, but we'll move on to those a bit later if we've got time. I'm probably going to stop just for 9, by the way, if you guys are wondering, so we can, yeah, we've got a little bit of time left. All right, let's finish up this question. This is a simple motor. So when it says simple motor, it doesn't mean it's simple to understand, it just means it's a very basic version of a motor. But actually the question they ask, and again, this stuff comes up just as often as using Fleming's left-hand rule, is explained in 1 way. So interestingly, it's only 1 way, but it's 2 marks. But you've got to explain 1 way that the motor could be changed to increase the rate at which the coil rotates. So, oh, amazing. Bridges in there straight away with increase the current. Absolutely spot on. There's about 3 different ways I think you could use of ways you could increase the rate at which it rotates. We've got to explain it. Do you want to see if you've got any other ones? What other ones could we say? So you're absolutely right. Increased current is 1. What else could I do? Say current or PD, both would be absolutely fine, basically, for this question. Swap magnets. Ooh, no, swap magnets, what that would do, that wouldn't make it go faster, that would make it go the other way. So if the coil was spinning 1 direction, you'd make it go the other direction. So not for this question. That's a useful thing to know if you talk about if it's going to reverse direction or something like that. Excuse me. Should have warned you to put the volume off. Yeah. If you, increase magnetic field strength. Yeah. That's perfect, Jody. Yeah. So basically, current or PD, I'm not going to remember to do this now. You could say increase the strength of the magnet. Magnetic field strength, same thing. Don't say bigger, by the way. Magnetic field strength. Or you could say wind more turns in the coil. That would be absolutely fine. All right. It's not a solenoid. No, it's the coil itself. You would make this magnet stronger. Okay. So I'm going to go with one of them. Now, if you just put those two down, you don't get marked because it says one way and that's in bold. Let's just go with increase the current, which is a mark, which is obviously good. We then got to explain it. So you want to have a go for this one here. If I was increasing the current, let's look at the question. It says increase the rate at which the coil rotates. So it basically goes faster. So what is it about increasing the current makes it go faster? It's easier than you might think, but you've got to actually explain it. Increase number of turns. Yes, you could say increase number of turns on the coil as well. That'd be fine. So basically, what is it that's increasing? If I increase the current, what's actually happening that makes it go faster? Amazing. Well done. Welcome if you guys are new. This is for higher tier only, by the way. This is double and triple, but this is high tier only content we're going through tonight. I'm doing magnetic fields. Greater force. Yeah, greater force, basically. So essentially, even though I feel like they were just trying to fill out an extra mark here, but it doesn't say how to increase the force. It just says to increase the rate it rotates. So if you increase the current, there's a greater force on the coil. Or if you said increase the magnetic field strength, there's a greater force on the coil. Or if you said more turns on the coil, there's a greater force. You see the pattern, right? I always use, bear in mind you guys have the equation sheet, like use the equation sheet to help you. If you use this equation here, force is equal to flux density, which is field strength, times I times L. Those three factors help the force increase each time. So if you ever get stuck, just talk about, well, if one of those goes up, the force goes up, so that you can then use that to explain like the rate thing, okay? So yeah, top tip is just look behind the question. Why are they not telling me force? Well, maybe I've got to get an extra mark for that, basically. All right. Is there any questions on this one? I'm going to move on to another motor type question in a moment, but that's the end of that one. Only 7 marks, which is not bad. If you haven't got any questions at all about physics and stuff, give me a shout. I've been a teacher for 11 years. Should we do a Fleming's left-hand rule one? Let's do it. Okay, right, let's have a go at this one here. So this is, what is this? Combined Science 2023, so only a couple of years ago, so you might have done this one. I'm not doing forces tonight, next week, all right? So let me get, I did have the screenshot up earlier. There you go. I'll post this again in my stories later. I'm doing forces of motion next week, and then waves the week after, EM spectrum, stuff like that. Okay. Would you say questions are repeated every year? Yeah. Not repeated exactly, but there's a lot of repetition. Like there are certain questions which last year before the exams came out, I don't do predictions, but I did like these questions come up quite a lot. I think I did about 7 of them, and like 4 of them came up. Like, you can't guarantee anything. Don't trust anyone who says predictions. But like, yeah, stuff gets repeated every year. And if you're doing, also you're going to get a certain amount of maths and things like that. But yeah, stuff gets repeated for sure. Oh, thanks, Football Focus. You got a big account, Football Focus. Man, proper BBC stuff. All right, this question here. We'll do Fleming's left-hand rule in a minute. Do you think you could tell me this word here? So it's basically another setup of the motor effect. We've got a whole big circuit, got a variable resistor, which we can use later, copper rod. But the first question is it's stationary, and the tendency of an object to make stationary is called, what do we think? Would you want to predict papers then? Yeah, do them, but I would treat them as practice. I don't like the word predicted. I think a lot of people make predicted papers. They're not often teachers, so they don't have any. If someone's annoyed at their predicted paper, they just delete comments. Like they don't. I'm a teacher. I have to face up to myself. If I say something's coming up and it doesn't, I'm gonna have angry parents on the way. Only teach science, yeah, mainly only physics these days. But yeah, no, do predicted papers. I'm not hating on predicted papers, but I would call them practice papers. They're just extra practice, basically. And I would do the actual official AQA papers, or Excel, whatever you're doing. Do them first. Obviously, save a couple for the exam, but Anything after 2018 you can do. Okay. Anyway, while I was rambling on, lovely stuff. A load of people would say got this right, which is amazing. Yeah, I'd be honest, I haven't taught chemistry and biology for quite a while, just because there's not loads of physics teachers at my school. So yeah, I'd love to get better at them. Maybe that's a job for the summer. But no, I'm mainly a physics guy at the minute, sadly. Hence the name. Otherwise, Captain Chemistry got a bit of a ring to it, isn't it? Okay, I'm going to keep this on the screen so you can see it. But the next question is, where does the copper accelerate? Okay. So right, again, it's only 1 mark. Okay, so don't stress out about it too much if you can't figure out. But you want to get, if you were on the stream 10 minutes ago, we did one of these questions. So what we got? Bum bum bum. What do we think we're going to have? Which direction is it going to go? Do we think? So basically, up, down, left, or right are the options. Am I doing tutoring? Yeah, I'd normally tutor a couple of people a year. I'm going to do like group sessions over Easter, I think. Like, going to make it quite affordable, but I'm going to make proper stuff for it and things like that, because I've always wanted to do that. So yeah, that's coming up this year. How much are you tutoring? I'm fully booked for individual at the minute. Sorry, bud. Okay, so people, all right, what on EV is anyone to guess? Like, be brave, people, all right? It doesn't matter if you get it wrong. That's really, really not a problem. But like, you need to know how to do it. But like I said, it's only 1 mark. So if you weren't here earlier, the thumb is the way the rod's going to move. The first finger is field, so that goes north to south, so that goes that way. The second finger is the direction the current goes in. Okay, so current, yeah, okay, that's a good question. Football focus. Let's have a look. So current always goes positive to negative. It's called conventional current. Annoyingly, it's not the way the electrons actually go, but we do use this for this diagram. So that's positive. This is negative. So it goes round this way. Basically, it goes round this way, round this way, round this way. Inside the copper rod bit, it's going to go through this bit. It's going to go through the copper rod that way, and it's going to carry on going in this big circle. All right. Now, I hope that's helped you try and figure out which way it's going to go. I don't know, you kind of can't do this without using your finger on the screen. This is the worst thing ever to do on a live stream. Right, north to south means my first finger goes down. The current's going that way. You see my finger going that way. Which way is my thumb going? It's going to the right. So therefore, the wire, the copper rod thing, is going to go to the right. So that's the question over here, which is that box ticked. I'll go back to the diagram in a second. Because current always goes positive to negative. So that's the positive side of the battery. So it's always going to flow around in a circuit, positive to the negative end. Okay. But yeah, that's called conventional current. But it's just the way in circuit diagrams we assume I can't spell at all tonight. Conventional current. That's the way it's going to go, basically. All right. Makes no sense. Yeah, I mean, I hope you, if you were around earlier, it's because it's going down. Yeah, it's going that direction. It's weird. I would like genuinely go, if you haven't, I'm not just plugging this because that's it, but if you have time to actually pause it and go on YouTube and check out my video on it, it might help you like do that. Why does the current come out on the positive side and not attract? I don't understand your question, Evie, sorry. Why does it not attract to what? But yeah, I said before, like, it's as important, where's my question from earlier? It's just as important that you can do this, you can say what each finger is for, you can say how to increase the current, etc. That's just as important as doing the direction. The direction, like, it's only 1 mark per question, I would say. It could be higher than that. Why go positive, negative? Oh, I see what you mean. Yeah. Should we get into it? Yeah, okay. So physicists make mistakes. Scientists make mistakes. Conventional current is not the actual direction electrons move in, which I think that's what you were talking about, Evie. Sorry, I didn't understand. So in a wire, electrons actually go, if you were to zoom in on the wire, they actually go towards the positive and away from the negative, because obviously they have a negative charge and they get attracted. However, physicists didn't know that, and they started making all these circuit diagrams in like the 1800s that said it went from positive to negative, so we now say it does positive and negative. Okay, but it is kind of wrong. But it is wrong. But yeah, it's kind of a bit like, you know, the plum pudding model. That's wrong, but we still learn about it. Like, it's kind of an example of that. Yeah, I know, it's annoying, but hey, at least you're smart enough to figure that out, so that's really good. But yeah, it actually doesn't go that way. But in circuit diagrams, that's the way we consider it to go. Okay. Right. Let's have a go at this last question and answer a couple more. So, increase the acceleration of the copper rod. So, if I wanted to make it move faster. So, this is, again, look at this. Look how someone asks the questions get repeated. This is basically the same question. Okay. Is space physics hard? No, it's quite a small topic, honestly. It takes about 6 lessons to teach if I was teaching it. Yeah, you can learn it. We'll do that in a future week. Amazing. Yeah, you guys are, yeah, you're getting it now. Fantastic. Literally, that's it. So you could say in 4 words, increased current, so force increases. So look what they didn't say in the question. They didn't say force. They said acceleration. So we know that from Newton's second law, F equals ma. So if I have a greater acceleration, it must be because there's a resultant force. So yeah, that's literally it. The other ways are exactly the same. If you were here 10 minutes ago, you could have more turns on the coil. Oh no, not turns. Yeah, you could increase the length of it. Yeah, increase the strength of the magnets. Triple content. No, don't do it now. Do it maybe in the summer, a bit, Evie. Depends how much time you've got. I would do. You can also do it as you go. Just get your teacher to send you a plan of the lessons, and then, or like when you do topics, then if you have one coming up, you pre-read it basically. But yeah, that's my job for the summer, to be honest with you. Okay, let's finish off this question, and then we'll maybe have a look for a trickier motor one in a bit. Okay, so this is another higher tier. It's a higher tier paper, but this stuff is for foundation. This isn't a motor question, so we can all do this, which is great. Can you do my school? My teachers do bad. I don't understand. Okay, we did this question similar to this earlier, haven't we? Let's answer it quickly. 2 marks. I reckon you guys can get this quite quickly. Very, very switched on tonight with this topic. So magnet used in demonstration was a permanent magnet. This is an iron bar with the same magnet. How could it be used to test if the iron bar is also permanent? So basically, what is the difference between an iron bar and a permanent magnet? So what do you reckon we could do? Can I join your school? No, sadly. But hey, you guys, you're lucky. Like I know you have loads and loads of stuff online. Like you have way more resources available to you than even 5 years ago. So you could learn loads of stuff yourself if you have the time to. Yeah, nice one, Daisy. Fantastic. Yeah, iron filings. No, iron filings would work with both. It'd be attracted to both, basically. Yeah, fantastic. Okay, so to test it, what we do is you'd basically put the iron bar next to both poles, so both north and south pole, and then if it's a permanent magnet, it should repel, as you guys said. So if permanent magnet, it should repel. If it's just iron, which was what it is, it will attract to both, just like our paper clips did in the question earlier. Should attract to both. Okay, that should be a nice, easy mark. How long are the lights? I'm going to about 9 tonight, so just under an hour. Okay. Could you say iron nail? Yeah, but I mean, there's the iron bar in the question, so you don't need to change what's in the question. Yeah. Sorry. Thanks, Eve. Right. If it's a permanent, I got confused. I was thinking if it is an iron bar. Okay. It should attract to. Thank you. One end, repel from the other. There you go. There's always a mistake every stream. You guys spot it. Fantastic. Lovely. All right. Let's finish off this question. Then I'm going to find. I didn't get it out. I'm going to find one with. If you guys heard of the split ring commutator, that kind of stuff, I want to find there. Yes. Sorry. I do make mistakes. Right. You mean what? I'm going back into 10 seconds. I've got a massive pile of past papers. I'm just going to find one with a tricky motor question in it, like a 5 marker. Right. Do you want to have a go at answering this? So this is a compass used by people doing TV, whatever. Explain how the compass provides evidence that the Earth has a magnetic field. It is 2 marks, all right? So I'll leave you that for a second. I'll be back in literally 10 seconds. How would I go about answering that one, do you reckon? All right, what we got? Opposite points attract. Compass points north due to magnetic field direction. Lines up with North Pole. Yeah, decent answers like this. Okay, so only CS a magnetic field. So you've got opposite points attract. 2 poles, north and south. So yeah, basically, if you don't know what a compass has in it, it's hard to draw on it. But basically, the needle has a little north pole here and a little south pole here, and then it basically spins. So it lines up with the Earth's magnetic field. So the first evidence would just be it points towards basically, or aligns itself with the magnetic field. It says point towards. Basically, you could actually add this question. You actually get marked for either point towards North Pole, which is technically magnetic South Pole, but it's not essential knowledge. It's not on your specification to know, but it's kind of interesting to know. Point towards magnetic North Pole, and basically it's essentially regardless of where you are on the Earth, or like doesn't matter where you are on the Earth. On the Earth. So basically, if this is the giant Earth, this is magnetic field. You could be here and it'll point that way. You could be here and it'll point that way. That's kind of the point of a compass, right? It always points that direction. Okay. South points north. Yeah. So you could either say it points towards North Pole. You could sort of point away from South Pole. That'd be fine. Yeah, I know. Fun fact, you know, this flips every like 200,000 years or something. So it could have flipped like tomorrow. It probably won't, but it can flip quite a lot. Which, if you're a bird, you're kind of a bit screwed in that case, because they rely on the magnetic fields for the migratory patterns and stuff like that. Yeah, I know. Crazy times. Right. Okay, we'll do one more question. Maybe try to find a bigger question on motor effect stuff. They do like asking about that. Where have we got? Nice motor effect question. Okay, another question on this one before we move on. Let's transfer that one. Unless I didn't print one out with motor effect question on it, that would be bad. Generators, that's not the one. Gonna get there eventually. All right, let's do. Here we go. This is the one. 4 marks. This could be 5 marks as well. Could be anything. All right. So this is the higher tieriest of higher tier questions. Is what we're going to go through. All right. Doesn't mean it's just for triple. It means it's combined and separate. Okay. But it's only higher tier question. All right. There's about a bit of the question which we have to go through if we have time. But yeah, we're going to finish about 9. We'll spend a few minutes on this one. Okay. So 4 marks for this one here. This is a motor. It tells you it's a motor, which is quite nice in the question. But there's a thing we haven't spoken about yet, which is this thing here, which is the split ring commutator, which is insanely important. All right. So the only thing you want to know, just before we can put it in our answer in a second, but we're super impressed if anyone knows what is or what does a split ring commutator do. What's the point in it? It's very important to this question. Otherwise, it will not rotate continuously, basically. Which paper is a separate paper? Oh, amazing. Nice one, Beth, and nice one, Alexandra. Very impressed. That's genuinely great. Yeah, if my students can recall that in a test, I'll be super duper impressed. Yeah, fantastic. It flips the direction or reverses the direction of the current every half turn. Okay. The reason it does that is to keep it rotating, because otherwise, basically, the coil will go that way, and then it'll go back, and then it'll go back, and then it'll go back. It'll just keep on going back and forth, essentially forever, until it loses energy because of air resistance and stuff like that. Okay, so that's the continuously part. We get 2 marks for that, and then we get 2 marks for talking about the motor effect. Okay, so in this question, and we can figure out, I don't think we're asked to here. No, we're not. You could figure out which way it's going to go. So this is the current's going in this direction. So it goes up through here and then back down through here. And that's north to south. So if you want to figure out, you could figure out that north to south is that way. The current's going this direction. So this way is going up. This way is going down. You don't need to necessarily, but because the current is going opposite directions, the force on the wire is in opposite directions. Okay. So let's have a look at the mark scheme for this one. It's basically the same mark scheme for, I don't know, all the questions essentially. So we'll say something like the 2 sides have current flowing in opposite directions. So the force, there's a force in opposite directions. Okay. Now, sometimes in a question like this, you get a mark for talking about what a turning force is. No, noise is back. Sorry. There we go. My bad. I thought I'd unmuted it. Anyway, so I'm going to tell physics and math tutors and not have such annoying ads. That would be amazing. Thanks. Yeah, that's absolutely right. Yeah, well done. Okay, so force in opposite directions. So basically up on one side, down the other side. So you have what's called a turning effect. You hopefully know this is called, you say turning effect. You could say a moment if you do separate signs. It's basically the same thing. You just say turning effect to the force. That's literally absolutely fine. So this opposite directions, which causes a turning force or moment. Out of interest, do you want to put in the chat how many people do triple science here? Just out of interest, because there's obviously some topics that are only on triple, which I'll do in a couple of weeks. But I want to try not to. I want to try and make everyone able to do the sessions. Otherwise, that's not going to work. How's your direction of the current? I've just done the positive and negative thing again, Evie. So you go down here, positive this way, negative this way. So that's the negative side of the battery. That's the positive side. Okay. Quite a few people do. Okay, awesome. All right. I wasn't sure how many people did. Yeah, because if you do triple, you don't do triple, you don't do space, which I think sucks. But or lenses or anything like that. So cool. We'll do those in future weeks. Awesome. Thank you for all the time. Okay. So next, and for this question, you don't actually need to talk about, like we talked about earlier in a question, current with flowing through a wire. You have these little magnetic fields around it. You don't need to talk about here for this mark scheme, but if it maybe there's a few more marks, you could mention additional ones, like we did the motor effect question earlier. The big one here is the split ring commutator. So we say something like the split ring commutator. You guys answered this earlier. You said it reverses the direction of current every half turn. So the idea is if the if the coil is going up on this side, when it gets to that side, if you imagine it moving, you want to go down again. Okay. So confused. Yeah, which bit? Could you help me out? Which bit are we confused on? Split ring commutator bit or the stuff before? Talk's not on GCSE. Everything. Yeah, that's why I said it's hard. I said this is the high tier stuff, high tier question. Right, let's go. Okay. If you were around earlier, we did this question here, which has a motor effect bit of the question. Okay, so in this question, we looked at if I have a wire with a current flowing through it, through a magnetic field, it moves. Okay, and if you're around then, we talked about it's going to move downwards. We figured out with Fleming's left-hand rule. I'm not going to go through that all again because that's ages. Okay, so things going to move. Now, in this question here, this is a motor. It's going to start rotating because one side will go down, the other side will go up, and it will turn like that. This looks horrible because it's just a weird looking diagram because this is what motors actually look like. Okay, but basically you've got, if you imagine it, like you've got one side of the wire, so one side of the coil, the arrow is going that way, so the current is going through this way, and then it has to go around and it can reverse back down to go this way to make a complete circuit. So in the other direction, it's going to be going this way. Okay, one side of it will be going down, so it'll move down. The other side will go up, so that's why it rotates. This is really hard because you can't imagine it's a freezed image, right? So this side goes up and then it goes round, round. It starts rotating because you've got the motor effect happening on both sides. Because the current is flipped, remember Fleming's left-hand rule, because the current is flipped, the force or the motion is flipped, so that will go down or go up or down depending on where it is. Okay. With the motor effect, the bit that's tricky is that, yeah, you've then got the thing called the split ring commutator, which is going to flip the direction of the current. But I'm going to stop there. People who said they weren't sure, does that clear things up or is anything specific? If you aren't sure, like, please don't feel bad. This is like a genuinely really quite tricky topic. I don't know about this paper, but usually these kind of questions are like, not that one answered. You're welcome. Why does it have to reverse here? Okay, so if you imagine I had the coil, imagine this side went up, and then it got to this side, it would just go up again, and it would just go up, and it would just go up, and it would just go up, and up, and up, and it would just flip back and forward. It wouldn't actually go round and rotate. As soon as this side gets to this bit over here, then the current flips, it then needs to go down, and then it needs to go up, and then down, and go up and down. Otherwise, it doesn't rotate. It will just, and I've seen a question like that before. It says, oh my god, that's a terrible diagram. You have a coil of wire and there's no split ring commutator, and it says what happens to it, and one side goes up, one side goes down, and then you just say it sort of oscillates back and forth a couple of times and then stops basically. Okay, it's all about this thing here, the split ring commutator, that reverses the current so that it keeps on going, it keeps on rotating. All right. So as it goes every half turn, what that does, if it splits the sorts from one brush to the other, or sorry, as it reverses the current every half turn, it basically reverses the force every half turn. So that it keeps going basically, which you don't need to save because it already tells you it rotates continuously. You don't get a mark for that extra. I hope that helps. This paper is 2018, so the mark schemes are slightly different. So I've kind of adapted the mark scheme a little bit more for this question because I've seen questions like this a bit more similarly on combined science papers. Every 1900, no, you do for generators. We'll do that in a future lesson. Generator motor effect, such a good question. Generator motor effect, okay. Here's my brief summary. Have I got room to do it up here? Yeah, group 2, okay. So motor effect, they work in very similar ways. So motor effect, you have currents that basically put in and you get motion or like a force out. Okay. For a generator, it's literally the opposite. Generator. For a generator, you put motion in. This is going to look messy, sorry. You put motion in and then you get current out. Okay, so we haven't been through the generator effect this week. We'll do that. It's on the schedule for like a few weeks' time because it's one of the hardest bits. But essentially, they're opposites. Okay, motor effect, you put current in, you get the thing moving. Generator, you move the thing, and then you get current out because it generates electricity. You get electric current out. Yeah, kind of like wind energy. For both of them, the reason I put a gap here is the reason they're so similar is because you need a magnetic field for both of them, basically. All right. Yeah, mad question though. Right. I'm going to call it there for questions tonight. If you have any more questions, I'll stay around for a couple of minutes. But yeah, my voice is starting to go and I've got teaching and stuff to do. But if you have any other questions, give me a shout. If there's anything you don't understand, like I would recommend, because obviously I've made them, I think they're quite good. Have a look at either the whole of paper 2 video or magnetic fields. I've also got exam practice on here as well with like Fleming's left-hand rule and stuff like that, if you find that useful. So Rock on Tuesday, I don't know a lot what I should do. Depends on where you know the content. I would revise content first, revise the stuff you don't know, then yeah, spam exam questions, learn from them. I would personally maybe try and do 1 or 2 past papers, maybe do one to figure out what you don't know, and then you can go from that. And physics and maths tutor, really, I'd say that's probably the best thing to do. But yeah, I'll try and post more. I don't want to do it yet because I think most schools leave it till quite late in the day in year 11 to do it. But I'll try and post more content and more questions on TikTok. I'm sure you can find if you scroll down. I did some more last year as well. But yeah, if you're always up 10, should you read notes or something? You don't have time to revise everything before Tuesday. Prioritize, okay? I would revise this, magnetic fields. If you do triple, I'd also revise stuff like, I don't know, lenses, space, like some of the trickier stuff. Yeah, but you'll be able to time to just prioritize. Maybe do a past paper and see what you don't know. Like, don't time yourself, just do it and see what you don't know. Anyway, right. This is next week, if you didn't know. So forces in motion, I'm not going to get through the whole thing. I'm just going to prioritize questions. You're welcome. If you haven't got any more questions, like comment or just send me a DM or something, all right? What's in space? You can find that out. I've got a video on it. Go find it out, okay? It's a whole topic. You've got to learn it, so find out yourself. All right. Anyway, thanks for joining, people. Appreciate that. That's the first one back for a little while. Thank you so much, especially people who stayed till the end and done loads of contributions. You're all amazing. Hope you all do well. Have a good week, and hopefully see you next week. All right. Evie, I mean, if you want, I love space. I think it sucks that you don't need space, but you won't get examined on it. Maybe save it for the summer, I'd say. Okay. All right. Bye for now, people. Have a good evening. Yeah, it'll get recorded up on YouTube, all right? So yeah.